Okay, class, we're starting on a new topic. The digestive system, also called the gastrointestinal system. Gastrointestinal system. Now, as far as medicine is concerned, a gastroenterologist is a internal medicine doctor that's specialized in gastroenterology. He can do your scoping, like your colonoscopy and so forth. Everybody needs to have at a certain age. And then if somebody needed surgery, it would be what we call a colorectal surgeon or a general surgeon. So the gastroenterologist does not do surgery, but he can do the scoping and everything, as you can see. All right, we'll go a little further here. Let's get into the subject. The digestive system has two groups of organs. The alimentary canal, or the gastrointestinal. Now see, we as humans have a tube within a tube. So the gastrointestinal system goes all the way from the mouth to the anus. So that's a tube, but it's in the cylindrical tube of our body itself. So this organ digests and absorbs food, our nutrients. You have what we will call the mouth, the pharynx. You know, we talked about the pharynx in respiratory, the esophagus. You go down to the stomach, then you're going to go into the small intestine, then you're going to go into the large intestine. Okay, also large intestine also is called the colon. Then you're going to go into the rectum and the anus. Okay, now that's the tube going all the way through. But then we have some accessory structures that are contributing to that tube. For example, the teeth, the tongue, the gallbladder, the salivary glands that you have contribute, the liver and the pancreas. And these send fluids into the alimentary canal to assist with digestion, absorption, and so forth. Okay? So we have the actual canal itself, the tube, and then we have these accessory structures that send chemicals into the tube, shall we say. Okay? The digestive processes include ingestion, that's the taking in of the food, or even the water for that matter. Propulsion, the propulsion propels it down. Now see, you're not always standing up, so you can't count on gravity. Maybe on your head, maybe doing exercises, maybe doing a sport, maybe sleep. We have mechanical digestion, which is churning the food up. The teeth start it, the stomach does some. Then we have chemical digestion, because we're using chemical enzymes. We're using enzymes. You remember that from ANP1. And then some food is absorbed. That's the food that we actually get the nutrition out of. And then some doesn't get absorbed, and so we defecate it out. Simple as that. Okay? So when we look at it, that again is how ingestion, bringing it in, mechanical digestion, propelling it down, absorbing it. That didn't get absorbed is defecated right there. Chemical digestion involving the enzymes. Okay. Now when we look at the propulsion, we have kind of two propulsion waves, we'll call it. Peristalsis. Peristalsis is a process where you contract, but you relax, move down. Then you contract, move down, then you contract. So it moves the stuff along. You also saw that when I talked about the ureters. Remember, the ureters did that too, to move urine down into the bladder. Now, another thing the ureters didn't do, though, what I need to do, this bolus of food right here in the small intestine, let's say small intestine. This bolus, I need to get the digestive enzymes to it. So we need to break it up some to get more surface area to get those juices to it. So these segmentation waves do this. They would come in right in the middle here and split you into two pieces. See, this keeps you going as a bolus, but this comes in certain areas and splits you like in the small intestine. Okay? So you're using a combination of both of these to keep you moving, to keep that material moving, both in the small and in the large intestine. Okay, let's go a little further. So how does the intestine know when the food is there? You have mechanoreceptors and you have chemical receptors. The mechanoreceptors respond to stretch. When the food gets to that area, you know it's there. It knows it's there, so it goes ahead and propels it or segments it. Now, the chemoreceptors primarily respond in osmolarity, pH. Okay. What's the end product? So some chemoreceptors say, oh, these are carbohydrates versus broken down lipids. And then they know what digestive enzymes to secrete from the accessory structures. And also internal to the digestive tract itself in the small intestine. Some of your what we call intestinal brush border enzymes that we'll talk about in the small intestine. So this initiates reflexes that get this going here. Reflexes also that cause secretion of the various digestive enzymes from the accessory structures. In other words, to say it another way, the intestine needs to know it's there before it's going to operate. The intestine needs to know it's there before it's going to operate. Now, we have intrinsic and extrinsic controls. We have intrinsic and extrinsic controls. So when we look at that, now here again would be these reflexes, just to show you. Some coming from the nervous system, some coming from the endocrine system in some cases. Okay, so that's what we said, internal tract, chemoreceptors, effectors. Okay. So enteric nerve plexuses, gut brain. We have a lot of nerves in this intestine, a lot of nerves in this intestine there. And so the intestine is just chock full of nerves. There are estimated 400 to 600 million neurons in your gut. There are approximately 100 billion in the brain. So the intestine has its own nerve supply up in there. Now it's modified by the extrinsic from your, now remember this would be the autonomic nervous system, not the somatic. Somatic handles skeletal muscle. So it's modified by that, but it can operate independently also with all these enteric controls. Intrinsic, or we can also call it enteric. Enteric means gut. Then we got the extrinsic. So the enteric nerve plexus, gut brain, initiates short reflexes within the tract itself. The long reflexes come from the autonomic nervous system. The autonomic nervous system coming in to do those long reflexes. Okay. That would be the, and just off the bat, the sympathetic nervous system shuts the gut down because the sympathetic is a fear, fight, and flight, and the parasympathetic speeds it up. Long reflexes in response to stimuli inside or outside the GI tract. Okay. Hormones also, because there are hormones, there are glands within the intestinal system too. Okay, let's go a little further. So we talked about this. So now we're looking at the coverings around the intestine. The coverings around the intestine. Okay, this is what I want you to think of. We're now to the serous membrane. Now this one, you remember the serous membrane in the lungs, the pleural. It allowed it to slide. In the heart, allowed it to slide. Well, the intestines, this long tube also needs to slide. It can't be stuck together, this long tube. So you have coverings around the intestine. Now, the way this works then is you have the peritoneum is a serous membrane. You covering the body, inside the body wall, we'll say, is the parietal peritoneum. Surrounding the intestines is going to be the visceral. So the space between the visceral and the parietal is the peritoneal cavity. Now, in certain cases, you have another little stick-off part here. So here's the dorsal mesentery. And matter of fact, let me say it like this. The way this reaches, so I'm going to come here. The way you get everything to the intestine is this mesentery. It comes off the posterior body wall. Because you can't just send, think about this, you can't send nerves and everything and blood vessels here, or the minute you moved around, they would snap. So you have a stalk. I'm going to call this a STALK, a stalk that comes, and all the nerves and blood vessels and lymphatics, everything is up in this stalk. That's how it gets there. That's how it gets there, which would be this stalk here. Okay. Now, in certain regions, you have a ventral mesentery, and what that does, like here's the liver, this kind of anchors things. So in certain regions, you have this ventral mesentery. Okay. Now, I'm going to this picture here. Certain organs that were here got buried back behind here and eventually became retroperitoneal. Retroperitoneal. Retroperitoneal means it's behind the peritoneum. So some things that were once here kind of went behind there, retroperitoneal structures. Okay, let's go over here. The peritoneum is a serous membrane of the abdominal cavity. Visceral peritoneum on external surface of most, that's the one next to the organ. Parietal lies the inside of the body cavity. Peritoneal cavity is between the two. In there you have some peritoneal fluid, just like you had pleural fluid and pericardial fluid. Okay, let's go further. The mesentery is a double layer. I'm going to come back here. The mesentery is a double layer of peritoneum, routes blood vessels and lymphatics in there, holds organs in place and stores fat. Retroperitoneal lie posterior to the peritoneum. Okay, intraperitoneal are surrounded by the peritoneum, which would be the visceral peritoneum. Okay. All right, so that's what you're looking at there. Part of the small intestine gets to be retro. Okay. All right. So we go a little further. Okay, class. I wanted to pick up a picture to show you some retroperitoneal structures. Remember we said that right here, some structures become retroperitoneal, and I mentioned to you that it's part of the small intestine. So just to show you something, here's part of the duodenum that's retroperitoneum. Duodenum is the first part of the small intestine. And you had here, and it went on back there. Now, the kidneys we already had mentioned, but that didn't have anything to do with GI tract. But this pancreas and duodenum went retroperitoneal right there. All right. So we go further. So that mesentery is a double layer of peritoneum that brings things in. Just want to be sure we're all on the same page there. Brings things in, those blood vessels. Some things are retroperitoneal. Here again is just a picture to show you. So we would have the parietal peritoneum, and these organs here are being surrounded by that visceral peritoneum. So right here, that the black area here is the peritoneal cavity, and this drawing is trying to show you, and that's a ventral mesentery right there. Right here is coming off. We'll be talking, that's called the omentum, and we'll talk about that. The greater omentum. I'll bring this picture back up. All right. We've gone as far as we can on this video, so I'm going to close this one. We'll start another.